Hello again. Welcome to part 2. So let's recap what we were talking about with the general solution of sine of x equals a half. So our first solution, we drew a triangle where the opposite over the hypotenuse was 1 over 2 within the circle. And that meant that the first solution was an angle of pi on 6. Then we realized that there was a second triangle possible to also get an opposite over hypotenuse of 1 over 2. And that solution was pi subtract pi on 6. By the way, if we tried to find solutions in this quadrant, or this quadrant, 3 and 4, we would not be able to because the opposite is negative and negative in those two quadrants. And it's positive 1 over 2 is the opposite over the hypotenuse. So we also realize that as we go around and find more solutions, we get 2 pi plus pi on 6, then 3 pi minus pi on 6, then 4 pi plus pi on 6, then 5 pi minus pi on 6, then 6 pi plus, etc. This shows us that for odd numbers of pi, we have one type of solution, and for even numbers of pi, we have another type of solution. So let's generalize our understanding. For even numbers of pi, it's pi on 6, the first solution, plus 2 pi, 4 pi, 6 pi, etc. So we represent this with 2n pi, where n could be any integer. For example, if we choose n equals 4, then we would get our solution being x equals pi over 6 plus 2 times 4, 8 pi, which would be whatever that is. 49 pi over 6, I think, off the top of my head. The important thing to understand is this 2n will always be an even number because 2 times a whole number gives you an even number. N can also be negative because you can also get negative solutions. Let's go back to our original drawing and we'll see what happens when you go negative. As you go negative, you also get negative 2 pi plus pi on 6. Then if you go another one, you'll get negative 4 pi plus pi on 6. So the general solution for even numbers of pi is working out for us. Pi on 6 plus 2n pi. When we did negative 2 pi plus pi on 6, that's just pi on 6 plus negative 2 pi. Now let's look at the other case where we're trying to find solutions for the triangle on the other side here. As we discussed, it was pi minus pi on 6, then go around 2 pi, and then 3 pi minus pi on 6, then 5 pi minus pi on 6. So you can see the pattern that we're establishing here. So let's go back. For the odd numbers, so we can say or, let me just put this in as a gap, or x equals, now it's going to be, this time we want odd numbers. So how do we create odd numbers of pi? Well, we say 2n plus 1 or minus 1, that will also work, pi. Let me get the pi. Now the reason this works, 2n always gives us an even number, but then when we plus 1, now we have an odd number because an even number plus 1 is always an odd number. And so you always get odd numbers with this expression for how many pi you have. And then we have to subtract pi on 6 because that was how we were getting our solutions for the second side, the second solution, and then the fourth solution, etc. So these are the two ways we can get solutions for x using a general solution. Again, n is an integer for this second part of